Hello together. This video explains you how to use the Festo API link master in a Siemens Profinet system. Actually, we're seeing that our system with the API is running in Profinet, and if we have a closer look on the demo board or the application, then we recognize here is our IO link master, and here we have the connected devices. One pressure sensor and a CPV terminal. Very important to know is per default, the IO link master has deactivated ports. Means there is no communication running. These ports, first of all, we have to activate. Therefore, we are going offline in our TIA project and have a look on the parameterization. We see here that is the default entry for the IO link master. And per default, there is nothing available. You have now to define the right size of your connected IO link devices. You see here the folder of the submodules, and we have now to decide how to use the port. If we want to use one port as digital input, we are taking this entry. If we have an IO link device with 2 byte IO, we are taking this entry. Do we have an IO link device with maybe 60 byte? Then we take this entry. If we want to deactivate the port, then the last entry would be this here. In our case, if we have a closer look again on our application here, you see here two devices are connected. And if we have a closer look in the manual, we are recognizing that 2 byte process data are enough for both devices. They are connected to the first port and the second port. Going back to our TIA project, we know now, because of the manual information, we have here IO link devices with just 2 byte IO. Taking this here to the first port, taking this here to the second port. The other ports are not used, we can deactivate them. So now we have made the basic configuration of our IO link master. If we download everything to the PLC, and we are going now online, we recognize here in our application that the ports are activated. That means we have from this point on an IO link communication to the devices. Furthermore, you may know this information called port qualifier information. This is a byte based on the IO link specification, which tells you how the connection is working to the connected device. If we have a closer look here inside the specification, then we recognize, okay, we have here the 1 byte, and the bits are meaning here device process data, validity, port device error identification, device communication, port operation, and so on. The details you find here in the figure 23. And with this information, we can check with the process data during operation if everything is working correctly on our IO link device. Go back, we know it is the last byte. Means here in this address range it is byte 12, and here it would be byte 15. We add now here just a watch table and have a look on byte 12 and a look on byte 50. And if we change the display, we recognize following value 1011. Going back to the specification, the meaning is, okay, this is the highest bit valid I/O process data from the device. This is the 0, no error warning occurred. This is the device communication, device detected, and it is in pre-operate operation state. And here we have the port is active. Yes, the port is active. And this is the value what we have seen now here in our TIA portal project in the online mode. Furthermore, we can now control the IO-Link device with the process data. If we have a closer look now on our devices again, then we recognize, for example, okay, here we have the output area for the second device, which would be, in our case, the connection to the CPV. Going back to the watch table, and using here QB10, we can now modify the value. And if we have now again a look on our application, we see the coils are switched on based on their functionality. That shows us the IO-Link communication is working. We can exchange process data. In IO-Link, it is very often necessary to change the IO-Link device parameters. If we have now a closer look here in our TIA project, and go here to the IO-Link device, then we are seeing here no information concerning the parameters of the IO-Link devices. These parameters here are IO-Link master related, means they are belonging to the behavior of our IO-Link master here. A parameterization of an IO-Link device is not working directly via TIA portal. We have at the moment 3 possibilities to do the parameterization. The first possibility is we are using the IO-Link master CDSU1. With this IO-Link master, we have the possibility to use our laptop, the corresponding software, and to do the parameterization of the IO-Link device. Per IO-Link specification, the parameters are stored remanently in the IO-Link device. That means after disconnecting it from this IO-Link master, we can connect it to the API IO-Link master, and the parameters will stay remanently available. This is option 1. Option 2 would be to use the Festo software for the parameterization of the IO-Link device. This software will be released in April 2021. And the option 3 is to use the mailbox functionality of IO-Link. Therefore, Festo has developed a function block which will be also released in April 2021. This function block is also usable during operation. Means with the function block you can change the parameters of IO-Link devices during operation without any problems. At the moment, there is no other alternative available as to use the CDSU, but we are changing this possibility as soon as possible. That was now a short explanation about how to use the IO Link Master. Thanks for your attention and have a good day. Bye.